Hello, class, once again. Today we'll be looking at the amount of substance and gas volume, the relationship between the amount of a substance and gas volume. If you check some of our previous videos, especially the one on moles, you will observe that the amount of a substance used in chemistry is known as mole. So we'll be looking at the relationship between mole and gas volume today. Welcome to Direct Stars once again. Today we'll be looking at the following: the relationship between mole of substance and gas volume. And you should be able to calculate the number of moles from a given volume of a gas, okay, by the end of the class today. And also get the volume of a gas from a given mass of a substance. Before we proceed, there are two important parameters that must be held constant for us to have this relationship, this perfect relationship. The first is temperature. Why temperature? The reason is when there is rise in temperature, there is always a positive effect on volume of a gas. So increase in temperature results in increase in the volume of a gas. And the other parameter we are going to be holding constant is pressure, okay? Because pressure has an inverse relationship with volume. If you take a balloon and you press the balloon, you know what will happen. Your mounting pressure will happen to the volume of the gas inside the balloon. It becomes compressed. So the more pressure you exert, the more the volume, gets smaller. So pressure has an inverse relationship with volume. However, when these two parameters are held constant, there is a relationship that exists between the amount of a substance and the volume of that substance. In this case, we're looking at gases. Okay. So the first thing we're going to establish today is that the volume of a gas, or the volume of 1 mole of a gas, is actually 24 dm³. Just let's take note of that. So for every 1 mole of a gas, regardless of what type of gas is involved, be it carbon dioxide, be it nitrogen, as long as the temperature and the pressure is held constant, as long as these two guys are held constant, 1 mole of any form of or any kind of gas will contain 24 dm³. Okay. What is the conversion of dm³? Because in most cases, our small volumes are measured in centimeter cube. Okay, so what is the relationship? How do we convert the centimeter cube to dm³? And what is the equivalent of dm³ in real life application? Okay, so we have 1,000 centimeter cube gives us 1 dm³. Please take note of that. And of course, 1 dm³ is the same as 1 liter. So this is the conversion, scale for the volume of gases. Okay, so remember, at standard temperature and pressure, what are the standard temperature and pressure? When pressure P is 1 atmosphere and temperature is 20 degrees Celsius, then the volume of 1 mole of a gas will be equivalent to 24 dm³. Let's take note of that. Okay, so which means if you have 2 mole of a given gas, you should have 48 dm³. Okay, let's say you have 2 moles of carbon dioxide at 1 atmospheric pressure and 20 degrees Celsius. Okay, so as long as the gas is in this standard conditions of pressure and temperature, we already know 1 mole of the gas is equivalent to what? 24 dm³. Okay, so that gives us a mathematical relationship. We'll just say the volume of the gas equals to mole times 24. Okay, and that makes 2 times 24 to give 48 dm³. Okay, so for 2 moles of carbon dioxide, we get 48 dm³ of carbon dioxide. So that is the relationship between mole and volume. Okay, so let's pick other examples. As we can see, we have relationship that have been established between mole and mass, because sometimes you may not know the mole of a particular gas in practical sense, okay, but you can easily tell the mass of that gas. Take, for example, looking at example 3. For example 3, we have 64 grams of methane. 64 grams of methane. So how do we get the volume of gas that is present in 64 grams of methane? You know, the first example we did using carbon dioxide, the relationship we look at is just strictly mole to volume. That is what we did. But this time we're trying to convert the mass of methane to volume. So how do I tell the volume of methane in 64 grams? All I need to do is convert the 64 grams to mole by using our general mole concept formula, which is the mass given over the formula mass. Okay, so in this case, we have 64 grams over methane. The formula for methane is CH4. Okay, and if you check your periodic table, you realize carbon is 12 plus hydrogen, which is 1. We have 4 atoms of hydrogen there, so we have to multiply that by 4. So this gives us 64 divided by 16. And of course, that gives us 4 moles. Okay, that gives us 4 moles. So now that we have 4 moles, we can easily convert to get our volume. Our volume is equals to mole times our constant for every 1 mole, which is 24 dm³. Okay, and then we have our 4 moles times 24. And that gives us 96 dm³. So you can see that even when given the mass of a gas at standard conditions of temperature and pressure, you can actually calculate the volume of that particular gas. At this point, we would like to end the lesson. Once again, thank you for watching. Please remember to hit the subscribe button so that you can always get update of new videos that is being dropped on this channel. Till we meet again.